All right, so here we are, one-step equations review. We're going to do just a couple problems together before we move on and have you guys try it yourselves. So at each point when I say pause the video, you'll pause the video and try one on your own to make sure that you've got it. You can do that either on the PowerPoint itself or on a piece of paper. So if we're solving this one-step equation, remember back, we say equations are like a bar, like lifting weights. Even if you don't lift weights, you've probably seen a person lifting weights and they have the same amount on each side. Because if they take off a big weight pallet on this side, they'll go, whoa, and they'll fall down to the ground, right? So you have to have it equal. Just like the bar, we want it to be equal. Or if you think about a scale, we talked about that before, a measuring scale. Then you've got these two pallets, okay, suspended by strings. And you've got the center column here, just holding it up. And if you have 5 pounds over here, okay, let's say, or if you have two 5-pound balls and two 5-pound balls over here, that's 10 pounds and 10 pounds. Okay, and we can imagine this middle part as being the equal sign. Well, what does that mean? It says this is equal to this. It's the same weight, right? But if I take off one of the balls over here, then we only have one, and this side's 5 pounds. But now, okay, my scale's going to tilt, right, to the heavier side, but also 5 pounds is not equal to 10 pounds. So we couldn't use this sign anymore. So in order to keep our sign, make things easy and simple, then we cannot just change one side of our equation. So that means that we have to always do the same thing to both sides of an equation. And we've said that before. We say, whatever you do to one side of the equation, you do to the other side of the equation, right? So as we're trying to solve, we say, all right, I want to isolate this variable. That's the word we said before. We want to get this by itself. Why do we want x by itself? Because that's the unknown. That's what we don't understand. So the reason that we are focusing on this solving equations is, again, because it is so crucial. You use it so many times, not only in math, but you can use it to make life a lot easier, especially simple equations like this in real life. I say in real life, you can use as many or as complicated of equations as you need to in life, but especially the simple ones can be an easy way to make things a lot easier instead of just doing it the long, hard way. So we want to get this by itself. How do we do that? We need to think about doing the inverse operations or the opposite operations. So the opposite of adding 3, so we say, what's being done to x? That's what I always say in my head. I always think, okay, what's being done to x? Well, 3 is being added to it. So the inverse of adding 3 would be subtracting 3, right? So I say, all right, let's subtract 3 from both sides of my equation, right? If I only do one side, then it's not equal. It'd be a lie. Now it's going to be tilted. So I have to subtract from both sides to keep it equal. Well, 3 minus 3 then gives me 0. Plus an x, we haven't touched, so those come down. Equal sign stays there. And 17 minus 3 is then 14. Okay, so now we have 0 plus x equals 14. Well, adding 0 to anything doesn't really change it, right? So now it's just x still, but adding 0 doesn't do anything. We bring our equal sign down once more, and the 14 we haven't touched. So now we have our answer. X, what was that missing value that we didn't know? Oh, x is equal to 14. Okay, x would have to be 14 to where we say 3 plus something gives us 17. It's got to be 14 for that to make sense or to be true. All right, if you need to replay that segment again or put it in a slower speed, you can always do that. Or let me know if you can't. Pause the video now, and I want you guys to try this next problem up here on the screen. I want you to try this next problem on your own, okay? So pause it, try it on your paper or on the computer, and then once you're done, then you can resume the video. All right, so is this what you got? Did you subtract 12 from both sides to get x by itself? If we wanted to isolate x, we wanted to do the inverse operation of what's being done to x. So the opposite of adding 12 would then be subtracting 12, right? So we do that to both sides, making this just become a 0, and now we have x is equal to 31. Okay, you can go ahead and pause it now while I get to the next slide.